Hey everybody, this is our first unit. It's called Thermodynamics. Now, the main concept of this unit is to study the relationship between a system, or in other words, the reaction, and its environment or surroundings. Okay, so we're going to start off with energy. So this unit is going to work in a couple parts. We're going to introduce the concept of energy and enthalpy. And then we're going to look at how they're going to work together with each other, and then how to identify the difference between them. Okay, so we've got our first lesson is about energy. And we're going to go through a series of learning goals. So the first learning goal for this is I understand that all stored energy originates from the sun. In this particular unit, we're going to be looking at two types of energy. The first one is the kinetic energy. Kinetic energy. Now, this we've always defined it as the energy of motion. And how we will be measuring this type of energy in this unit is going to be through a measure of temperature. So we're going to measure it with temperature change. Then we have our other type of energy, which is called potential energy. And remember, all stored energy originates from the sun. So whenever I'm talking about where does potential energy comes from, that comes from the sun. And this one is stored energy. And for the purpose of this unit, it's stored energy in bonds. So we're going to be taking a look at when bonds open bonds break and bonds close. Okay, so the next learning goal is that energy, the conservation of energy states that energy cannot be created or destroyed, and it can only be transferred. So like I said, in this unit, we're looking at the relationship between the surroundings and the reactions. The relationship of a system. And I want you to get used to me saying system. That means reaction. So whenever I'm saying system, that means reaction. Whenever I'm saying reaction, that also means system. And environment, which can also sometimes be referred to as the surroundings. Now, I'm going to talk about how the magnitude. So magnitude, I'm not talking about negatives and positive. We're looking at everything without a sign of positive or negative. So if we're just looking at magnitude, we can say that the energy of our reaction or system is equal to the energy of our environment, because whatever happens, those guys are exchanging or transferring energy amongst themselves, so they will be equal. So therefore, if the reaction is gaining, I should spell that correctly. If the reaction is gaining energy, that means the environment is losing energy. Now, if we're looking at it from the perspective of the reaction, which we will always be looking at it from the perspective of the reaction, if it is gaining, that will then refer to endothermic. Remember, endothermic means we are absorbing, gaining, need energy. Now, if the reaction is losing energy, so if the opposite is happening, again, we are looking at it from the perspective of the reaction, then the environment is gaining energy. Oh, I am just spelling, there we go, gaining energy. And this will be then considered exothermic. Okay, now, When we are trying to determine if a reaction is endothermic, oh, there we go, endothermic, or exothermic, we will always look at it from the perspective of the reaction. Again, when I'm using the word reaction, that is the same as me calling it the system. We will never look at it from the perspective of the environment. So if you're looking at a word problem and it's saying the environment is losing energy, then we bring it back to the reaction is gaining energy, therefore it is exothermic. If the reaction is losing energy, then it is exothermic. I think I messed that up. Reaction is gaining, it is endo. If reaction is losing, then it is exo. So it's very important that we're talking about it from the correct perspective. Okay, so now there are three different types of systems. When we're looking at these systems, there are three different types of systems that describe the relationship of energy and matter. We're going to explore what that looks like. The first type of system is called an open system. So basically, I'm going to draw a diagram so that you can see it. Here we have a system. Okay, it's a container. And the container is open to the air. And let's put some water in there. What can happen is matter can exchange with the environment and within the system. So we're going to say matter can be exchanged. Now, if you're having a hard time visualizing what matter is, we're going to say that it's oxygen that can be going in and out of the system. Now, the other one is that we can say energy can also be exchanged. So energy can be exchanged as well. And for the sake of energy, I'm going to say that we can add heat. Now let's solidify that. I'm going to say both matter and energy can be exchanged. Okay, and some examples is a pot of boiling water. Okay, that is open to the system. A mug full of coffee. Okay, let's go to a closed system. So a closed system, now the container is closed. Okay, we still got some water in there. Now, nothing can enter and nothing can exit. So we can't have matter going outside and inside. So matter cannot be exchanged. Now, what about energy? We can still heat that container up. You can put your lunch container with the lid on into the microwave and it can still have energy transfers. So we can have heat go in and out of this container. So let's now solidify this concept. Matter cannot be exchanged or transferred, but energy can be transferred. And when I'm using the word transferred and exchanged, they mean the same thing. So an example of this, container, I'm going to say closed container. Closed container of food or lunch. Think of your lunchbox. Now, the last system is an isolated system. So what I'm going to do is I'm going to kind of put this in a box. Okay, oftentimes isolated systems such as thermos have some sort of insulator between the full first layer and the second layer. And again, we're going to fill this container with water. Now, matter cannot be exchanged. So matter cannot be exchanged. So therefore, again, when I'm talking about matter, I'm talking about oxygen, maybe water vapor, any of that. When you think about a thermos, when we put food or water into a thermos, we put it in there so that it stays hotter or colder for longer. What a thermos is doing is it's preventing heat from entering and exiting as well. So energy cannot be exchanged. Okay, so that's heat. Okay, the better your isolated system is, the longer it will stay at the remaining temperature. So I'm going to say both matter and energy cannot be exchanged. All right, let's look at some examples here. So I've been talking about one, it's a thermos or one of those insulated coffee mugs. And then the last one is called a calorimeter. Now, we're going to talk about calorimeters later on in the unit, but I want to introduce you to the word. So don't worry too much about what calorimeter means. Just going to let you know that it is a closed system. So that is our introduction to lesson 1. Make sure you guys have this all copied down, and I will see you guys in class.